Thank you. So, hello, privet. It's an honor to be here on behalf of Samsung Internet team discussing how to be immersed in the web. First and foremost, I am Diego Gonzalez. I am a senior developer advocate for Samsung Research in the United Kingdom, and I am a Google developer expert in web technologies focused on immersive web. Now, I would like to first see some hands if you are aware of what Samsung Internet is. Okay, that kind of reflects on the market share, but good. So for everyone that is not aware, Samsung Internet is the company's web browser, and yes, Samsung has a browser. It's based on the Chromium engine. The latest release that we have, well, the latest beta that we have is 9.2, and it's based on M67. Now, it's an evergreen browser, and that is pretty cool because it means that we're constantly committed to updating the browser to include the latest and greatest web features. So if you have an Android device, you can pretty much install it. You do not have to have a Samsung device in order to install it. As long as it's running Android L or higher, then you can install it and start testing. You can start playing with things like Web Bluetooth, gamepads on the browser, progressive web apps, and the topic that brings me here today, which is XR on the browser. Now, again, if you want to do it, this is the URL where you can get it. And you might be asking, why would I want to test or why would I want to use this browser? Well, it turns out that the browser itself actually has a lot of users. Here in Russia, we are in 4th place after Chrome, Safari, and Yandex. 5% of users. That is a lot of people. If you go to Europe, if you go to North America, we are in 3rd place, and we have a very big active user base. So if you're creating experiences that will run on a web browser, be sure that you're testing where your users are browsing. So let's go and dive into the topic. Before we start properly talking about WebXR, I want to kind of like do a 101 on XR. Can I see some hands if you are aware more or less of AR or VR, or you've used or you kind of like coded for this? Okay, it's good because then this is going to be a good introduction on what you're going to be able to do powered by the browser. If you're creating VR experiences, there are some things that are very important. First of all, you need high precision, and you need also low latency. These two are fundamental in order not to break the immersion experience of the user. Why? Well, because if you're actually moving inside a virtual space and the images are not refreshing accordingly, then it's going to break the illusion. And of course, if we're talking about these type of platforms, there's a lot of data that we're getting. Data from how you move, data from, for example, the security requests that you would have to issue. If you want to do AR, you would have to get access to the camera. So there's definitely more and more that we need to be taking care of when it comes to XR. On the other side, there are some things that I want to get clear before we start talking again about specification. Hardware, content creation, and the distribution. And we're going to be talking about the current state of all these three right now. Starting with hardware. When we're talking about hardware, there are possibly, you could think about head-mounted displays or other XR devices. Other XR devices could be, for example, a phone, or could it be stationary screens that are moving in reaction to how you are actually moving. Now think about, we can have head-mounted displays that are opaque. Think about head-mounted displays that can be transparent. And you can have devices like a phone that would use video pass-through to do the experience. So 6 degrees of freedom depending on the technology that you're using, if you're doing some image recognition, for example, of the space, or if you're just viewing some content as if it were a window. That's why we call it the magic window. So that's more or less the landscape of hardware at the moment. Let's talk about content creation. And content creation is quite interesting because we have kind of like SDKs per device, and this is not necessarily good, especially if you want to create immersive experiences and you're not a super big company with unlimited resources, or if you just want to play around with creating these type of experiences. And the other option are frameworks that are based on an open standard. So, of course, the frameworks based on an open standard seem like a better idea, so let's just dive a bit more into them. And actually, before diving into them, let's get our heads around the idea of having SDKs per device. Let's say you want to create an experience that's going to be running on an Oculus device. Great devices. The problem is that if you want to do something for the Rift or the Rift S, then you have 3 options. You can either use the PC SDK, which means that you need to be doing C++, maybe that's not your cup of tea. So you might want to move to using some Unreal Engine integration or some Unity integration, in which case, again, choose C++, C#, or the Boo language. And that covers 1 device, 2 devices if we count the one that hasn't been released. Go and Gear VR. Again, you have a mobile SDK, which in this case is the one that works with the Android NDK as well. C++, you don't want to do that, then you can integrate it with Unity or Unreal. But again, C#, Boo, and the upcoming Quest documentation as of yesterday in the Oculus website indicates that you will be capable of easily porting your experiences. So you can kind of see how it gets a bit more complicated and more complicated. And this would be for only 1 device of family. We're not counting the Vive, we're not counting Microsoft mixed reality devices. It's just pretty much for 1 family of devices. Let's move on to distribution. You have pre-approved closed environments, which is what we like to call the walled gardens, also known as the app stores. For some experiences in VR, you're pretty much asking your user to wait valuable time to download hundreds of megabytes for an experience that they might only use once. So we really need to be careful what is the kind of interaction that we're asking from our users. And the other one, again, the open ecosystem, which the benefit is that we can have multi-device, multi-platform, and they would be progressively, or they can be progressively enhanced experiences. Meaning that if I'm on my phone, I can be doing VR with the magic window, but if I move to a higher device, like for example an Oculus Rift, then I can enable with the same code the controllers, and the experience would pretty much just migrate. Now, the benefits that we get from this are obvious, and if we are all sitting here, it's because we actually like a bit the web, I would be assuming. So we need an ecosystem that's fast because for proper VR, and let's say on desktops, browsers should be able to get 90 frames per second of the experience that you want to do. Frictionless, why? Because I don't want to go to an app store to put my credit card information and it kind of like, I want to enjoy the experience now. And the benefit that we're having with this open ecosystem is that the only thing that we need to start enjoying or experiencing VR is a URL. It's a website in the end. So if I have this URL, I can share it with all of you. You go this in your phones, and you should be able to some extent, enjoy this experience. Of course, progressive and progressively enhanced, which is what we discussed earlier. Social, and the web is built and has a lot of capabilities that allow us to do social multiplayer interactions. Latency is kind of an issue there, but let's wait for 5G. Accessible. We want content to be accessible, and not only on the traditional sense of the way that we are actually making the content accessible for everyone, but also that the content can be accessible from multiple platforms and multiple devices. And immediate. If I get the URL, I click on it, and I am already in VR. And democratic, because everyone and anyone can create their content if they want it. That's the concept of WebVR. It's our open, accessible ecosystem, the web. We are able to now do XR, meaning VR or AR, from the web browser. The specification is currently under development, so it's changing, and it's changing quite fast. But from the W3C website, we get that it's the specification that describes support for accessing VR and AR devices, including sensors and head-mounted displays on the web. Basically, what we are allowing now is a new attribute in the navigator that pretty much links to an XR object. And this XR object, what it does is that it's going to be able to give me information about the XR devices that are connected to the machine. So I should be able to, for example, query what are the XR features that I have. Is it something that supports motion, 6 degrees of freedom, 3 degrees of freedom? Because based on this information, you need to set up the environment, or the framework will set up the environment for you to actually create your experiences. It also has a list of all the XR devices that are connected to the machine, and it will handle connections, disconnections, etc., etc. We can see here, for example, one of the methods. This is actually running in the screenshot from Chrome Canary, which I believe is, at the moment, the only browser that is implementing the new specification, which is coming. But we can see here that, that it has a method that's called supports session mode. And I want to point support session mode because the way that the browser would do WebXR is the following. First, it's going to check if the type of session that we are requested is supported. And by session, remember when we were looking at opaque, transparent, and the magic window? This is where we can translate. We would get the session mode, which could be inline, meaning that I can have an HTML page, and in this HTML page I have, let's say, a canvas, and in this canvas is the one that's reacting to how the phone is moving or how the devices are moving. I can actually ask as well for an immersive VR, in which you get you're going to get the full control of the screens, or immersive AR, which is pretty much similar, but with AR devices and all the sensors that come with it. Now, once you do this, you need to, let's say you requested to see if the type of VR that you want to do or XR you want to do is supported. The browser says, yes, it's supported. So you need to advertise this to the user. Generally, the way that people are doing this is by putting an icon that looks more or less like this on content. So if you see something like this on the web browser, it means that you can probably click. And once you click, then you're going to be inside the immersive world. Now, we need to wait for user activation event, and this is kind of like similar to when, I don't know how many of you have had the issues with web audio, that some browsers, there was this whole debacle that you need to kind of like user input in order to, it's kind of the same, it's similar. It's for security, it's for privacy, but at the moment, you wait for user activation event, and once that happens, then you can request a session. And this session, of course, is the one that's going to allow you to create the experience. If this session succeeds in its creation, then you get a loop in which you're actually displaying your content. Now, the session itself will poll device information. So you're going to know at all times when you're polling what's the position, for example, of the controllers, of the headset. And based on this position, then you can just pretty much use other APIs to render this. Notice that WebXR does not render. WebXR is to access information from the VR devices. It's not the one that's painting. If you want to paint and you want to do 3D on the web, how do you do it? WebGL with Canvas, exactly. And you present, of course, the image to the user. So, supported browsers, and it's a bit more complicated than this. This is just kind of like the nice ideal scenario. At the moment, we have, let's say, 2 versions of the specification. The first one is the one that's current, which is considered kind of stable, which is WebVR 1.1. That's the latest. It's supported by Edge, Microsoft Edge. They use it for the Windows mixed reality devices. Mozilla Firefox, which is supporting it since version 55, if I'm not mistaken. Samsung Internet. we were actually the first browser that was supporting the specification because some years ago we put out the Gear VR, so it was kind of like mandatory that we wanted to integrate web technology there. But Chrome, it's still under, still behind the flag though, and Oculus browser, which kind of seems odd, you know, to see the Oculus logo there. And the last one, which is Helio, which is the browser that is now on Magic Leap 1 devices. And as I was saying, the only browser that I'm aware that's supporting to some extent, because it's not working, I tried it a couple of days ago, it's Chrome Canary and Chromium as well. That would be, if you enable it, supporting WebXR. So, also something interesting that's going on with browsers is that we're seeing new browsers appear, and we're all kind of like used to the whole idea of desktop browsers, traditional desktop browsers. Then we saw the rise of mobile browsers. Very cool. But now we're kind of seeing a lot of new browsers that are coming to the market. First browser that came actually with this functionality is with Samsung Internet for Gear VR. It's a separate browser that runs when you are using the headset. You also have, for example, following suit, Google Chrome for Daydream devices. It's not, I don't have the logo there, but the one that looks like a pink Firefox, that's Firefox Reality, which is a browser that they're actually putting in, they're aiming to be on every single immersive platform. The Oculus browser, which started as Project Carmel, very interesting and and possibly more interesting is the rise of these new browsers like Supermedium. These are browsers that are actually focused only on WebXR content, and Helios. So support for hardware, again, depending on what you want to do, which platform you want to target, then you can see that if you're using Google Cardboard, and I'll address this, the big elephant in the room. What about iOS devices, right? No Safari on the slides. No, it's. So basically, it kind of is supported. I mean, Apple is not implementing. They are in the community group. They haven't implemented it yet. The problem is that a couple of weeks ago there was a controversy because they were changing the way that allowed the polyfill to work. Short answer, it works. It works. I think they were going to backtrack on some of the decisions of removing the, I think it was the device orientation automatic events, which is pretty much the one that you need to make it work with the polyfill. But Google Cardboard, you can pretty much use any browser that you want. Samsung Gear VR, you have Samsung, Oculus, Firefox browsers available. Oculus Go, Oculus browser, Mozilla. I'm not sure. I think it is released, already, the Samsung Internet for Gear VR, and Daydream. And if you're talking about 6 degrees of freedom, then you get Oculus Rift. You can use it with Firefox. You can use it with Chrome, same as Vive, and Windows Mixed Reality is the one that actually is allowing the mixed reality headsets with Edge, and now I believe with Firefox as well. And of course, if you're doing AR 6 degrees of freedom, then Helios on the Magic Leap. So pretty much this is all to say, if you create an experience or part of your website that is leveraging some of these APIs, you can be sure that it's going to work on any or all of these devices. And this is looking a lot better than, for example, just the one slide that we saw with one family of SDKs. Who's using it? There are tons of demos. Well, not tons, but there are plenty of demos. These are actually quite old because it was a bit late yesterday and I couldn't get the new screenshots. But basically, we have things like car configurators that are running in the browser. For example, this one by a company called Little Workshop for Renault. The second one is kind of cool one because it's called Dance Tonight. It's a collaboration between LCD Sound System and Google. And here the interesting thing is that you are in the point of view of this weird stick figures that dance, and you can actually record and be incorporated into it. So it's kind of cool. We can see how we're leveraging social experiences. This one, the third one, is a game that was created in collaboration. BBC, Good Boy. We actually had some input on this one in London, a game time travel by Doctor Who, and this is to actually fly. I forget the name of the telephone booth. I'm sorry, I'm not British. But and a painter by Mozilla, which is actually a clone of Tilt Brush, which is to actually paint and create your own things. With the added benefit that since it's web, you can pretty much take anything that you're designing or creating and with a link, share it to anyone. And hey, look what I've just done. So other people can see it because, again, it's web technologies, and that's kind of cool. So kind of like the twist here is that when I'm talking about being immersed in the web, I'm not actually referring to the fact that we can now do VR and AR in the browser, because that's kind of like so 2016. What I'm referring to is that VR is now, sorry, XR, and sometimes I use the terms when I say VR and AR and XR, think about they're the same unless I specify the contrary. But basically, it's that XR is already immersed in a web platform, and this has huge advantages, because it means that if you want to do payment, you have the web payment API. If you want to do audio, special audio, you can use the web audio API. You can use web Bluetooth to control things from the VR environment. You can use the gamepad API if you think that the controllers are not suited for what you want to do. You can authenticate yourself as well in this type of environment. So there's a lot of things that you can just play with just because it's immersed in this web scenario. Now, another of the benefits of being immersed in the web is that you probably already know all the technologies that you need to know to start creating these type of experiences. And we can see that there's a lot of folks out there that are coding with JavaScript. This is based pretty much on the Stack Overflow survey of what are developers pretty much preferring as a coding language. Another of the benefits of being in the web is that you have a huge community and you have lots of open source projects in which you can contribute or just pretty much use. Let's say two of the possibly the most famous ones are BabylonJS and A-Frame. There are different approaches to creating VR experiences. We're actually going to see, if there is a bit of time, we're going to see briefly some code. But you also have like a symbol to create, to manage all the multi-users, for example, in your experiences. 3JS if you want to just code it a bit more manually, or platforms like Janus VR or others. Also, this, of course, means that we now have an inclusion of 3D assets now in the web, and this is kind of like something that we need to be careful because instead of an image, which we can optimize, 3D models are a bit more complicated and a bit larger in file size. Luckily, there's been also work on gltf, which is a transmission format for 3D content. It's meant to be used on the web. You can get content pretty much created yourself and exported from Paint 3D, Blender, more professional tools. Sorry, Blender is a very professional tool. Or just download from tons of repositories online like Sketchfab, Google Poly, or Microsoft Remix 3D. So we're going to see some small examples. I'm not going to go through all the code because nobody wants to see boring code, and you can come and ask me after. But I just want to see two examples to kind of get some ideas flowing on how you can incorporate. Don't think that XR on the web means that you need to create virtual worlds and games and this. There's a lot of clever ways that you can use it. And again, since it's immersed in the web, we can just combine it. And we can combine it with web components. In this example, for example, I'm using BabylonJS to create a web component that pretty much allows me to put any 3D model in a web page by just putting the custom element. But with the added benefit that BabylonJS has a very good support for WebVR, so I can just put one line of code, which we're going to see, and it allows me to create something that will look like this. Now, I have the demo here. I'm going to show it in the end. I just want to finish first the slides, and then we can see this. The component itself, it's kind of there hidden. This is a 3D model, so you can take the mouse and pan and move it around. Let's say you have a store or you have some sort of website that wants to take advantage of this type of technology. The component itself, it's loading the engine scripts, which is BabylonJS. It's setting up the 3D environment. It's loading the 3D model, and it's listening for changes. So I can change the background color. I can change the model itself. You can do it from JavaScript. You can do it from an attribute in HTML. It's just a typical web component. BabylonJS, what you need to know, so this is like BabylonJS in 10 seconds, the introductory course. BabylonJS, everything happens in the create scene. Everything that you put in the create scene is the thing that's going to be rendered, and you can easily add VR to the scene with just one line of code. And there's actually quite easy way of doing this. I wrote a blog post about this. This is just to experiment, but if you're interested, that's the URL where you can find the instructions. Another thing that we can combine, quite interesting, is PWA. So let's, in this case, I'm mixing A-frame with progressive web apps, and the idea is that I want an experience that will be offline, will allow VR, and I'm actually going to remove the browser Chrome, wink, and I want no barriers to the experience itself. So we're going to see this running on either of these phones as well. Also something cool, notice that some browsers, we were actually the first browser to do it. Mozilla is doing it now as well, and I believe Google should be following suit soon. Add to home screen, you kind of get this now new icon. If you press this icon with, for example, Web APK, you should be able, the browser should be able to download this application and make it work offline, and with Web APK, it would just look like an application normally. Limitations, basically, at the moment, performance is a bit lower than native. Resolution is also a bit lower than native, but we're working on it. AR is still experimental, and it won't be in the first release of the specification that's coming in a second revision. The specification is still under development, so I would stick to WebVR 1.1 unless you have a lot of time to be correcting and upgrading some demos, but WebVR 1.1 is actually working and stable and supported in major browsers. And of course, the size of assets on mobile connections might be too big, so you need to learn how to optimize your models in 3D software. And what's next, before we go into just some quick code? AR on WebXR is coming in a second revision. We have 5G coming for a better, faster experience, and this is going to be key changing for latency, especially if we want to do multi-user experiences. And we have new devices with growing capabilities. That's why at the beginning I said, 3 degrees, 6 degrees of freedom, it's kind of like relative and changing now, because now we have headsets that are 6 degrees, playing well with controllers that are 3 degrees, so just make sure that your experience is progressively enhanced. And thinking about declarative depth, that is something that might be coming soon as well. So we're just going to show, is that 30 or 40? 30, okay. 40, ooh, okay. So we're just going to very quickly show a couple of things. Sorry, let me just cancel this one over here. Good. Okay, so I just want you to pay a bit of attention to create scene, the create scene function here. Everything else is just kind of like the template that you would need to get a basic scene in BabylonJS. There's one line that's commented, which is the VR helper. This is the difference between having, let's see it here. I believe it's this one over here. And let's cross our fingers. Oh, how lovely. It's not finding the GLB of the chair. Okay. Trust me, it's there. Let me just... Anyway, in the meantime, let's go and see the other one. This is the A-frame one. This is the one that uses the PWA. I just want you to kind of see what's the structure. You have relatively normal looking HTML page. You have a scene, and in the scene, it's actually kind of readable. We have gltf models, 3. One's called best chair, the other white chair and blue chair. Position, scales, and rotation, background color that goes with all of this. This one I've added a manifest file, and I've added a service worker as well. So the cool thing about this one is I'm going to unplug here. I'm going to cross my fingers. We're going to take this other phone. And okay, so let's see. Let's see. Okay, so you can see here my phone. I'm going to go into the browser. I'm going to refresh just so you can see that I'm not cheating. Waiting for user activations. Once I click and I give it, you can see that now it's actually answering and responding to how I'm moving. You can see the indicator that I was telling you in the bottom of the page. If I press this indicator, since I don't have a headset, then I can take this and put it in a Google Cardboard, and you can see how, again, it's responding to movement. It was kind of like a few lines of code. And the last and most important thing, you can see the add to home screen. So I'm going to press it. Look what's going to happen. There's kind of like a new feature. Okay, you can see that I got a notification now. The notification says that the best chair is installed. Now, this is a website. So I can just go into my application screen. And look at this. I have an application that's called Best Chair. The browser actually made it into an APK and put it as an application. Just so you can see, I'm going to open it. Look that there is no Chrome here. So I'm actually using the full width of the window itself here with the 3D models and images. And let me see one more thing, just so you can see that I'm going to remove connection. Right, I don't have any data because roaming is expensive. And now I'm going to go open Best Chair as well. And what you can see here is a VR application that's running offline in the browser. It's not connected. No browser Chrome because I decided to take it off, but it's running offline in the browser. I think that's it. If you have any questions about the code, you can come and see me so you can be sure that the other example does work because I've tested it plenty of times yesterday. So thank you very much.
У нас есть 5 минут на вопросы. Если вы стесняетесь задавать их по-английски, вы можете задать их по-русски, и мы попробуем перевести также криво. Так что все в порядке. Мы не стесняемся говорить плохо. Поднимайте руки, мы подбежим. Нет, никто не хочет спросить, как ему рисовать в VR что-нибудь? О.
Yes, I'm just, here is a question. Yes, thank you. It was great presentation. Thank you very much.
Thank you.
My question is about STL models. So basically, STL models, I mean 3D models.
Yeah.
So we may render with it any kind of model.
Pretty much OBJs, STLs, FBXs, GLBs, GLTFs. Yeah.
And what about, for example, 3D maps, like we have some Google 3D maps? Google Maps in...
Maps.
Yes.
You could use it. For example, BabylonJS has a way that you can create some sort of terrain. So once you get the terrain, I don't remember if it's with an image information or with actually an array of data, and it will create the terrain, for example, if you wanted to do that. There are ways, yeah, of creating the 3D model.
Yeah, so basically my question is about 3D models, and we can render any of them.
Yeah.
Thank you.